Hi, pre-calc. We are still going to be working on getting good at simplifying trigonometric identities. First thing we should do is go over all of the identities we need to know in order to do this. So the first set are the reciprocal identities, right? And these are all identities that you can change. If you have 1 over cosecant and you bring him upstairs, he would be a sine. If you happen to have 1 over sine in a problem, you could always write that as cosecant. Or you could think of it as, if you bring sine upstairs, he would be the reciprocal. Okay? The quotient identities are the ones where you change everything into sines and cosines. Tangent can be written as sine over cosine, or if you have a sine over cosine, you can write that as a tangent. Notice all of the angles must match. Angles must match. If they don't match, you can't write it as a tangent of that same angle. And now we get to the good ones. Okay? The most powerful ones are the Pythagorean identities. Okay? And this first one right here, you must memorize this one. You must memorize this one. And it's sine squared of theta plus cosine squared of theta, and that equals a 1. Okay, if you think about a unit circle, where this is the cosine, the x is the sine, and the hypotenuse is 1, and if we did a Pythagorean theorem, cosine squared plus sine squared would make a 1. Okay. Now, you can have other versions of this. We're not going to memorize all the different versions, okay, but we could rearrange. I'm just going to call that rearranging. Rearranging. Because sometimes in the problem, you don't have it exactly like this. For example, what if we saw 1 minus cosine squared of theta? If this was minus, and all of this was on the right, then that would equal sine squared of theta. What if we happen to see sine squared of theta minus a 1? What if the 1 was subtracted and on the left, and that was the only thing there? That would mean that the cosine squared would have to be on the right, which would make him a negative cosine squared of theta. Okay? There's a whole bunch more, of course, but this is what you would do. Now, how do you make, let's put a box around this one. This is the most important one. We have to memorize that. If there's some things I would write on the top of my test, this might be one of them. Everything else you could rearrange or you could make. Okay, so the second Pythagorean identity you can quickly make at the top of your test. How do you do that? So you take this first Pythagorean identity, okay, and you're going to divide each of the terms by the same thing. I'm going to divide by sine squared of theta. If you divide one term, you divide all the terms. Sine squared divided by sine squared makes a 1. What's cosine squared divided by sine squared? Well, using the quotient identities, cosine divided by sine is cotangent, except this is squared, so this would be cotangent squared of our angle theta. And what's 1 over sine? That's going to be a reciprocal identity. 1 over sine is cosecant squared of theta. And there you go. There's the second identity, dividing all the terms by sine squared. If we did some rearranging, what if you were simplifying a problem and you saw cosecant squared of theta minus cotangent squared of theta? What if the cotangent squared was over here? What would be left on the other side? That would be equal to a 1. What if we were working with a problem we saw 1 minus cosecant squared? 1 minus cosecant squared. That would make the cotangent squared be on the other side, but it would be a negative cotangent squared of theta. Okay, so sometimes making these across the tops just so you can rearrange with your finger without making all possible combinations does help. And how do we make the third one? Let's start back with our original Pythagorean identity. start with the first one, and I'm going to divide all terms by cosine squared this time. Cosine squared of theta. Okay, so the first term, sine divided by cosine, is tangent, and this is going to be tangent squared of theta. Cosine squared divided by cosine squared makes 1, and 1 over cosine makes secant squared of theta. Okay, and there is your second, or your third Pythagorean identity. So what if you were doing a problem and you saw secant squared of theta minus tangent squared of theta? If it was secant minus tangent, the other side would have a 1. Okay, I wanted you to be very careful here. All of these Pythagorean identities, okay, the terms must be squared. The terms must be squared. Notice how it's tangent squared, cotangent squared. Okay, so for example, if I was working with a problem and I saw sine of x plus cosine of x, what could I replace that with? Could I replace it with a 1? No, because these are not squared. No, you can't replace it with anything. It would just have to stay like that. So be careful. If you have squared things, think Pythagorean identities. If you don't have squared things, then think about some of these other identities or other things you could do. The even odds, remember the ones that I want you to remember are cosine and secant. They're negatives. Their negatives disappear. He's cosine of positive x. This is secant of positive x. The other guys have their negatives pop out in front. So sine of negative x is a negative sine. This is a negative cosecant, negative tangent, negative cotangent. They don't lose their negatives. The negatives pop out in front. Only cosine and secant become positives. Okay, that was a great review because we need to know all that in order to simplify some things. So let's start with this first one here. First thing I notice is their angles are negatives. So I think we definitely are going to be using some of these even odd identities. Let's just put them here. Okay. Except this is sine squared. Okay, so what this is essentially is a sine times another sine. Let's go ahead and break that down for you. Please put an equal sign. This is sine of negative theta. And when it's squared, there's another trig function with the same angle. And then we have plus cosine of negative theta times cosine of negative theta. Okay, so this is essentially what we have. A sine times a sine plus a cosine times a cosine. Now, what happens with these negatives? The sine function has the negative pop out in front, and this negative sign is going to pop out in front. Okay, so we're going to have a negative, negative. Why don't we just write a positive? And then we're going to have sine of theta times sine of theta. So there were two negatives that popped out, but they made a positive. Okay, what happens to cosine's negative? Oh, their negative just disappears. Okay, so essentially, we don't have negatives for him anymore. He's cosine of positive theta times cosine of positive theta. Now that does not look very simple. Okay, remember we're supposed to be simplifying. So what can we do here? Why don't we write sine times sine as sine squared? And then cosine times cosine, we're going to write that as cosine squared. Okay, now are we done? Is there anything else we can do? Remember, these are squares. If you have squares, it's not a bad idea to go back and look at those Pythagorean identities that we have. And the one that has sines and cosines, sine squared plus cosine squared can be combined down to a 1. Final answer. Okay? You must show work line by line. You must have equal signs. How's your trig identities looking? Okay, number two. simplify by writing the expression with a common denominator. Okay, so here's another technique, making a common denominator so we can add terms. So we have 1, and then we have minus this fraction. So let's go ahead and take their suggestion. Sometimes when you have fractions, combining them into one fraction does make it more simple. So we have 1 minus cosine squared theta over 1 plus sine of theta. Okay, so the first thing I'm going to do is put some parentheses around this quantity. Okay, that's an entire quantity. So when you're making your common denominators, let's put 1 over 1. This first fraction here is going to need the common denominator. So he's going to get 1 plus sine of theta. And what you do to the denominator, you must do to the numerator. Okay, so I need to see it written 2 times. And what do we have now? The first fraction is 1 plus sine of theta. Well, let's see, they both have the common denominator. They both have, so I'm just going to write the common denominator once. And then you can go ahead and add your terms. This is minus cosine squared. Okay, so let's just take a vote. Do you think we are done? Yeah, it definitely seems like we could do more stuff than this. Okay, so the question is, what should I do? Should I cancel this with this? No, you can't cancel when there's plus minuses. Again, maybe you should put parentheses around this entire numerator. Plus and minus signs is a quantity. Okay, you could only cancel with multiplication. All right, so we can't cancel. Let's look at this numerator here. Is there anything we can do? Maybe we should take a look at this cosine squared. That seems like an identity. What identity is that? That seems like the sine squared of theta plus cosine squared of theta identity. Except this says negative cosine squared. Oh, but there is a 1 right here. Maybe what I could do is take 1 minus cosine squared and then replace that 1 minus cosine squared. Let's see, if this was a 1 minus the cosine squared, that would leave us with sine squared. So I'm going to replace these 2 terms with sine squared of theta. And then there was still this other plus sine. And in the denominator, we have a quantity. Okay. Can I cancel here? Or here? The answer is no, because there's plus signs. You cancel an entire quantity or nothing when there's plus signs. So what are we going to do here? There's really not much to do on the bottom. I like that they're all sines, so I don't want to replace sine squared with cosine squared. In fact, that would be like going backwards if we did that. So we're done with this idea. How about if we factor? What can we factor out of the numerator? We could factor out a sine. They both have a sine. So that gives me sine of theta. Take one of his sines away. And then if I take one of his sines away, that's going to be plus 1. And the denominator is also the quantity 1 plus sine. Ooh, are you getting that exciting feeling in your belly? Can you tell we're getting close? Okay. Are we allowed to cancel this quantity with this quantity? Yes, they are exactly the same. Okay, I'm going to put a note here. We're going to cancel the quantities. Cancel the quantities with parentheses. If it's exactly the same, it cancels. And that leaves us with sine of theta. Now I know we're done. Okay, that had a lot of steps to it. Example 3 wants us to also take a look at some factoring. So let's go ahead and take a look. at the terms that we have here. So we have this term, and then since this is multiply, that's all the same term. So we have two terms in this problem. Let's see. Well, each of the terms has a cosecant squared. Okay, so I think since their clue said factor, I'm going to factor out cosecant squared from each of the terms. Okay, so terms are found between the plus minus signs. For example, x squared plus xy. Okay, the plus sign determines the two terms. So let's put an equal sign. I'm going to take cosecant squared of x out. So parentheses. What do we have left on this first term? We took both of his cosecants away, so he's a 1. Remember, you have to put something. If we distribute it back in, would that work? Minus sign. If I take cosecant squared out, that would leave us with sine squared of x. All right, let's take another survey. Do you think we are done? No, of course we're not done. We got to try some more things. Let's see. They are squares. Remember, when you have lots of squared things, we could think about our identities. The identity I'm going to look at here is maybe this sine squared one. If we have, let's see, what is the identity? Sine squared of x plus cosine squared of x makes 1. Can I replace 1 minus sine squared with something? So if this was the 1 and the minus sine squared was over there, that would leave us with cosine squared. So inside of the parentheses, why don't we go ahead and replace that with cosine squared? Cosine squared. Okay, let's see. Is there anything else we could do? We might be able to replace cosecant squared with an identity. Let's see, what's the identity with cosecant squared? Oh, I could replace that with 1 plus cotangent squared. Do you think replacing one term with two terms is a good idea? Is that going to be more simple? No, that's just going to make this problem bigger. So I don't think I want to use Pythagorean identities. Well, the only other thing I could do is change cosecant squared into sines. Okay, so that would be 1 over sine squared of x times cosine squared of x. All right, so let's see. What's more simple, 2 terms or 1 term? Okay, so let's put this together and make 1 term. 1 term. This is all numerator. Okay, so this is cosine squared of x, and the denominator is sine squared of x. Now, what's more simple, a fraction or not a fraction? How can I write this as not a fraction? Cosine divided by sine is cotangent squared of x. I definitely think we are done now. Okay, this next one doesn't come with any clues at all, does it? Do you think it would be a good idea to maybe look at the Pythagorean identities? No, because nothing is squared. All right, I see sine, I see tangent, I see secant. Those don't match at all. All right, so what's another technique you remember learning? We can change all the terms to sines and cosines. Let's make everything be sine and cosine, and then we'll have something to work with. Okay, so equals sine of x is good times tangent. Well, that's sine of x over cosine of x. Secant is 1 over cosine of x. Okay. I kind of like what I see because in terms of denominators, they're common. Those are common denominators. Remember this first fraction right here? Sine of x, this is like over 1, so this is all numerator. So they already have a common denominator. 1 times cosine is cosine. You don't make common denominators when you're multiplying, only when you're adding and subtracting. So the common denominator, cosine of x, is already there. And the numerator is sine squared of x minus 1. Okay, that was nice. I like how the common denominators were built in. Now, what about the numerator? Ooh, I see a squared power. Whenever you see a squared power, what does that make you think of? So let's go find the Pythagorean identity that has sine squared in it. Sine squared of x plus cosine squared of x, that is a 1. So is there anything I can replace sine squared minus x with? Sine squared of x minus 1, minus 1. If the 1 was over there, sine squared of x minus 1, then the cosine squared would have to go over there. Oh, that would be a negative cosine squared of x. Okay, so the numerator is negative cosine squared of x, and the denominator is just cosine of x. Okay, can we cancel anything? First of all, a negative divided by a positive is going to be negative. There's 2 cosines in the numerator, and there's 1 cosine in the denominator. So when you cancel 1 cosine, his power goes down by 1. So now it's just cosine, but we still need an angle, and that would be x. Okay? So, for example, if we have cosine squared of x, what that means is cosine of x times another cosine of x. So there's still 1 cosine left. All right, number 5. Any ideas here? I like that they're all the same trig function. Okay, so we see cosecant minus 1, cosecant plus 1. Oh, those are almost the same. They're almost the same, but they are different. One's got a plus, one's got a minus. What do we call things like this? These are conjugates. These are conjugates, okay? Conjugates are so awesome when you multiply them out. So let's go ahead and multiply them out. Firsts would be cosecant squared. Now I'm not going to do the outers and the inners. I'm going to go straight to the lests. Minus 1. Okay? What is this thing called when it's something squared minus something squared? Yeah, it's called a difference of squares. A difference of squares. Difference of squares are so awesome, okay, because something is squared. Oh, something is squared. We might want to go look at our Pythagorean identities. The Pythagorean identities. Can you replace this with something smaller? What do you think? Yeah, cosecant squared minus the 1. So the identity we're looking at is right here. If we minus the 1, we'll be left with cotangent squared. Cotangent squared of angle theta. Okay, this is the power of conjugates. Conjugates make difference of squares. Difference of squares, okay, we use the Pythagorean identities. Okay, once you get familiar with these techniques, they'll come to mind more quickly, and then you'll know what to do. And the only way to get good is to get a lot of experience trying different problems. Okay, the last one here gives us a hint. They want us to multiply. Okay, why do you think they want us to multiply these things? Because they're difference of squares. Okay, we probably could have come up with that without the hint, right? So in the numerator, we're going to get 1 minus cosine squared of x. And in the denominator, we have cosine squared of x. Okay, can we cancel these? No, we can't cancel, all right? I'm going to put some parentheses around that quantity. It's a quantity when you see plus minus signs. All right, so which technique are you thinking we should go with? Since this is a squared power, okay, we should think about the Pythagorean identities. The one that has a cosine squared in it is sine squared of x plus cosine squared of x makes a 1. So what would we replace the numerator with if we saw 1 minus cosine squared? If we have the 1 and then minus the cosine squared of x, we would be left with sine squared. So in the numerator, I'm going to replace that quantity with sine squared of x. And then we also have this denominator here. Okay. Now what's more simple, a fraction or not a fraction? Not a fraction. So how can we write this not as a fraction? Well, since this is sine over cosine, we could write this as tangent, and then they're both squared, and they're both of x. Okay? Hopefully you're starting to realize what you can do and where you should go the more problems that you do and you see. I can state the reciprocal quotient and even odd identities. I can derive the 3 Pythagorean identities. Okay? Do not go into this test saying, I'm just going to memorize all of them. Just know how to make them. Okay? Derive means to form, to make them. I can simplify using several techniques. Okay? And the techniques that we've learned is change to sine and cosine. Use identities. Okay, when you see squares, you see things that are squared, think about the Pythagorean identities. And if they're not squared, don't try to use Pythagorean. If you see conjugates, okay, you should multiply because they make difference of squares, and then the Pythagorean identities. You could factor. You could multiply. You could make common denominators. Okay, we're going to practice all these techniques next time. Thank you, Pre-Calc.